Welcome to the deep dive. We're digging into some source material you sent over, and this one, well, it's definitely unexpected.
Okay.
We're talking calculus, integration specifically,
Mm.
but applied to, let's say, evaluating manure output from cattle.
Right. Cattle raised on silage, specifically mentioned in the source.
Exactly.
And, for anyone maybe in a college math course right now, hitting differentiation and integration,
Yeah.
this source brings up a really interesting question, doesn't it?
Yeah,
How does that math apply here?
totally. It's not your standard physics problem, is it?
Not at all.
So, our mission really is to unpack just how integration is the right tool for understanding something, well, so variable and practical, I guess.
Like cow output on a specific diet like silage.
Yeah, forget those perfect curves in the textbook for a second. We're kind of heading to the farm with this one.
And the crucial thing to get here is that manure production, it isn't like a steady tap, right?
Mm.
It varies a lot, throughout the day. Depends on feeding cycles, digestion, how active the animal is, stuff like that.
So you don't get the same amount every single minute.
Definitely not.
Okay, so let's break that down. If you wanted say, the total amount over a full day, 24 hours,
Mm-hmm.
you couldn't just measure the rate at like noon and multiply by 24?
Precisely. No, that wouldn't work.
Yeah.
It wouldn't capture the peaks and the troughs, the variations.
Right. So this is where integration steps in.
This is exactly where it comes in. If
Okay.
you can somehow model that rate of production.
Like grams per hour, maybe? As a function of time?
Yeah, exactly. Let's call it FAT, grams per hour.
Yeah.
If you have that function, then integration is, well, it's the mathematical tool that adds up all those constantly changing instantaneous rates over the whole time period. They're basically finding the area under the curve that rate function makes over time.
And that area is the total amount.
That area represents the total accumulated amount.
Yeah.
It's like summing up infinitesimally small amounts produced over infinitesimally small bits of time.
Got it. So the definite integral of that rate function, ft, from time 0 to time 24 hours, that gives you the total grams produced that day.
That's the idea.
And the source mentioned cattle and silage. That specific feed, that must be a big factor in what that rate function ft looks like, right?
Oh, absolutely. Huge factor. Silage is fermented forage, so it digests differently than, say, fresh grass or grain.
Okay.
That would definitely influence the timing, the quantity of waste,
Yeah.
the whole pattern,
So the actual shape of that ft curve depends heavily on the silage diet.
for sure. And getting that function. That likely comes from, real-world data.
Empirical data.
Yeah, researchers or maybe farmers carefully measuring output over time for cows specifically on that silage feed.
Right, the data collection. That's the hard part in the real world before you even get to the calculus.
That's often the challenge, getting good data to build the model.
Okay. And could you, scale this up? Thinking beyond just one cow over 24 hours, maybe the total output from a whole herd?
Conceptually, yes. It gets more complicated, obviously.
Sure.
But if you had a model for how output varies, not just over time, but maybe also based on, say, individual cow differences.
Like weight or age.
Weight, age, maybe even slight differences in how much silage they each ate.
Yeah.
You could potentially use more advanced integration, like multivariable calculus.
Or maybe summing up integrals for different groups within the herd.
For summing up individual integrals based on some distribution of those characteristics in the herd, yeah, to estimate the total herd output over a certain time.
Wow, okay. That's pretty fascinating. It really shows that integration isn't just, abstract math about curves. It's actually designed to handle things that change and accumulate in the real world, even messy biological stuff.
It really is. The messiness of biology, as
Yeah.
you put it, fits perfectly with calculus's power to sum up these variable quantities. So this source material, it's a great practical example. It shows that these concepts you're learning.
Like defining a rate function, using integration to get a total.
Exactly. Those are actual tools. They're directly applicable for analyzing real, tangible things, even, kind of unusual things like agricultural output.
It really connects the math to practical problems, sometimes in the most unexpected areas, like this one.
Definitely.
So, okay, bringing it back to you, the listener, maybe deep in a calculus course right now, what's the big takeaway?
Well, I think it's the core ideas behind integration. Handling rates of change to figure out a total accumulation. It's just incredibly versatile.
Right.
This whole dive into cattle and silage, it's really just one specific, maybe surprising application.
Yeah. So here's a final thought to chew on.
Okay.
If integration can give us a quantitative way to understand something as specific as manure output on a particular diet, What other things out there, maybe seemingly unrelated things, could be understood or quantified using the math you're studying right now?
That's a great question. Think about it. Where else do things accumulate based on changing rates?